Today, we're going to speak about, how to locally enforce some of the policies that you've been defining as part of your Venafi platform. Let's start with what we see happening in Kubernetes today. As you sort of, think about Kubernetes and the cloud-native solutions, very often we see that these applications are heavily distributed. They are obviously containerized. Most of the containerized workloads are highly ephemeral, which also means that any of the identities that are associated with these workloads are also ephemeral. So which means you're mostly managing ephemeral identities that are required for these workloads. So the point I'm trying to make is, when you run these containerized applications in a container orchestration platform like Kubernetes, the number of identities, the number of workloads, the number of microservices, the number of containers, the number of clusters themselves are exponentially growing, which means that many times as you sort of, think about what those identities should be, how should they be governed, what should happen, all of those become extremely difficult, and it is important to sort of get a good handle on that. Obviously, one of the things that we are talking about here is around machine identities and why it is critical for securing your modern containerized environment to create that true zero trust architecture, whether it is for your workloads that are running in your environment or whether they are part of some service mesh, whatever that might be. So there is a need for machine identities to be managed at scale. So let's talk a little bit about what is required, and as you sort of think about the various different scenarios and what that means. We very often talk about protecting the ingress, and that's very common in the world of Kubernetes, and it may be very common in the other world as well, when you think about data centers. So when you think about data center where applications are running, let's say in an Apache or fronted by an F5 load balancer, but very often you think of an identity and stamp it to that load balancer, ensure that when somebody says hello.example.com, you get routed appropriately to the service that is available and running. Most often we talk about how to automate these machine identities that are attached to different load balancers or your workloads that require these identities, whether it is to inject that certificate into an instance where Apache is running or into some other server that's running. It's similar here in the world of Kubernetes as well. You have these containerized workloads. They are all accessible, or at least one of the services accessible through an external endpoint that is managed through an ingress, and that essentially allows anyone who is accessing this service outside of the cluster to be able to get access. And that ingress point, as you can imagine, needs to be secured. And very often we think that if there is a load balancer or something else where there is an identity attached, I don't need to think about these ingresses. But protecting every public ingress across multiple different Kubernetes clusters is something that is absolutely required as part of the threat mitigation. The other aspect that we think about, very often in terms of mitigation is around stopping rogue CAs. And this is something happens very often when somebody is operating a Kubernetes cluster. They have workloads that they need to run. They also need an identity that needs to be injected into various different workloads. Easiest way is to bootstrap some CA that is either generated through OpenSSL or brought in from something that that is generated through some CA or something of that sort, which is not approved by the organization. These self-signed certificates are pretty common in the world of Kubernetes, especially as people think about, what's the best way or the fastest way for me to get something started or get something rolling to secure my workloads and get a machine identity for that. And then obviously there is the use case around service mesh. Service meshes obviously are something that is being very commonly used these days, more in the context of managing traffic at scale. getting a much richer observability around how various different services are used within an enterprise, and also to ensure that all of the workloads that are running and are part of a mesh are mutually authenticating to each other to ensure that all the lines of traffic are encrypted. Ensuring that you have the ability to prevent any kind of man-in-the-middle attacks in this service mesh environment is also something that is critical to sort of understand. So what you see on the right side, obviously, is the result of not managing it, whether it is denial of services or elevation of privileges or intercepting or spoof data for communication within the service mesh. All of these are challenges or things that we want to sort of avoid. And I think that's the whole purpose of ensuring that one, you don't have a failed audit at the time when there is an audit, and also ensure that you have better control over all of these identities, and also cover all of the use cases that are required to avoid these misconfigurations and also violations. One big area, as we sort of think about ensuring that we can mitigate all this risk, is to get a proper comprehensive visibility of all the machine identity data across all the clusters within your enterprise. When you look at the ability to sort of the use cases or the scenarios that we talk about, we need to ensure that there is automated alerts and notifications. There are audit logs. There is the ability to define multiple trust levels, and a machine identity issuer that is specific to a cluster that ties back to a platform where you're managing all of the CAs. So in this case, a machine identity issuer that is connected back to your Venafi platform. Policy controls within Venafi. How do you identify various different policy violations, and ensuring that when there is a workload that is deployed, that workload has an identity that is specific to that, and when that workload is destroyed, any identity associated that with goes away, and all of the various different dependencies on identities that are required for mutual TLS and things like that. So that becomes a sort of a requirement from the perspective of how you manage your machine identities, just as you manage it in your data center within your cloud native environments as well. So basically, as you sort of think about, we've been doing various different things, whether to get visibility, and as we get visibility, to automate all aspects of our enterprise to have a machine identity management solution in place. We should be able to extend the same capability that you have within your data center into your cloud native environments, irrespective of where their cloud native environments are running. In this specific case, if your Kubernetes is running in your data center, same rule applies. And if it is a managed Kubernetes offering through a cloud provider, still the same rule applies. Still the same rule applies. So irrespective of where you're running your Kubernetes environment, you should be able to have this capability within your environment to ensure that you have full enterprise coverage for your machine identities. As you see here, there is the Venafi TLS Protect. You have the Venafi TLS Protect for Kubernetes. There is the InfoSec team. There's a platform team that is sort of operating and running Venafi environment, the Venafi environments, connecting to the Venafi environments rather, whether they are running in a specific Kubernetes environment or running managed Kubernetes environment or running OpenShift. They have the ability to use the Venafi enhanced connection capabilities that will provide secretless authentication into your Venafi platform from the cluster. So that way, once you connect the Venafi platform with the cluster using something like JWT that gets mapped to a service account token in Kubernetes, you're essentially connecting a cluster to the Venafi platform that you're managing. So that essentially sort of provides the ability to ensure that you have a mechanism through which you can support automation for different teams. And as part of that, you also have the ability to validate that issuance through the approver policy. The approver policy essentially is very simple. If you sort of look at this example here, this is a long list of various different properties. But if you sort of focus on something that I've highlighted, there is something that says allowed, and it says common name of some kind, and it is also required true. But most importantly, in the plugin section, in the bottom, you see that there is a reference to Venafi connection name and a zone, which is something that you should be very familiar with. That is the policy folder where the policies are defined. While those policies can be referred to as centralized policies, anything that is defined here explicitly, whether it is the fact that there should be a spiffy ID associated with it, certain constraints which define the minimum and the max duration, whatever the private key algorithm min max size is, common name, all of those are locally defined policies. So in this case, you're essentially defining central policies through the policy folder called enterprise CA/team A, and then some local aspects which are defined here. Essentially, when enforced, all of them together are enforced. As a takeaway, there is a URL there, TLS Protect for Kubernetes. Go try it today, and if you have questions, ask us, and I'm happy to help, happy to walk you through all the various different things that I talked about. Definitely give TLS Protect for Kubernetes a try from Venafi.com. Thank you so much. This is Sitaram Iyer, and I am happy to chat with you today. Thank you.